In this video, I'm going to go through all the different types of inference procedures and how to do them on your calculator. They're all going to be found under the stat test menu. And what you're going to want to do when you're there, we got one proportion z test, one proportion z interval, two proportion z test here, two proportion z interval there. Here's your two samples t interval. We're never going to do two samples z. We're not going to do a z interval. So this would be like a one sample t interval, two sample t interval, two sample t test, and the one sample t test or a paired t test. You're just going to use t test. Linear regression t test and t interval if you have all of the data. And we've talked about chi-square tests on here. So I want to start out with a one proportion z interval. So here under choice A, all of these are going to look the same for the intervals. They're going to say X and N and confidence level. So in this example here that I have in the book, 246% of the people in the sample of 439 said yes. People thought teens should wait to have sex until marriage. So what I'm going to do, X is the number of successes. This has to be an integer. So 246 people said yes. This would be 246 divided by the 439, or not divided by, your sample size is 439. Your confidence level was 95%. This has to be a decimal, 0.95. Calculate. And then I can just write this down for my do step. I could literally just write down the confidence interval for my do step, and that would earn full credit. What you need to be aware of here is if this, say instead of the 246, they said like 54% of the sample said that people should wait. So 54% of 439 is this. The problem is error domain. You're not going to get a confidence interval unless you have, this has to be a whole number. I can't have 237.06 people saying yes, teens should wait. You have to round this to the closest integer. So in this case, it would be 237. So if you get a domain error, any kind of interval that you do for proportions, two proportions interval, it's going to be the same thing. Group one, say 12 out of 20 students pass the AP. Group two, 18 out of 22. Confidence interval, say it's 90%. Okay, now I see the confidence interval. I see the two sample proportions and the two sample sizes. So what you're going to want to do is make sure when you're doing a one or two proportion z interval, you have whole numbers for x1 and x2, or that's the number of successes. Okay, let's talk about t intervals. So if I have a paired t interval or a paired t test, for all the t data, you're going to have two choices. Data. So if you have the actual data, you'd have to enter that into a list, and then you could go ahead and do this. So there's some data in list one. All right. So if I have a t interval, I have my data in list one, say the confidence interval level is 98%, calculate. There you go. I have my confidence interval, my sample mean, my sample standard deviation, and my sample size. If I go back and I do the same thing for t interval, but now I put statistics, maybe you just have the summary statistics. So put in the mean, put in the standard deviation of the sample, your sample size, your confidence level, same thing. You're going to notice very similar for two sample t interval data, you would have to have two separate groups now. And your frequency is always going to stay at one. You're never going to pool. That's always going to be no. Statistics, you're going to need the sample mean and standard deviation of each group and the sample size. Never going to pool. Always leave that as no. So that would take you through all of the intervals. Now let me move over to the tests. For a one proportion z test, you're going to put your null value. So maybe you think 41% of people, whatever. X is still got to be number of successes. It's got to be a whole number, your sample size. And then what's your alternative? Not equal to, less than the null, greater than the null. Say it's greater than 0.41, calculate. It will give you the test statistic, Z, the p-value. Notice it doesn't say p-value, it's just p hat. The hat's kind of hard to see, and and the sample size. For two proportion z-test, very similar. You have your two groups, 12 out of 20, 18 out of 22. Just make sure when you choose your alternative, group one on your paper is group one in the calculator. So group one, maybe it's not equal to. And you could see it'll give you your test statistic. It will give you your p-value, the sample proportion for group one, group two. This is the combined estimate and the two sample sizes. I want to show you something else that you could choose to do. If you hit draw, what it will give you, I shouldn't have that box plot in there. It'll give you the sampling distribution with the shaded region that you can draw. It gives you the p-value and the test statistic. So if that's even better and you don't want all that extraneous information, you can just take that option. All right, let's go to paired t-test or just a one sample t-test. It's just going to be t-test. So you have the two choices. Do you have all the data? If you do, let's say, I think this was around numbers in there were around 60, the list, less than, greater than. Okay. You get some information here. There's no way the p-value is 1. So let me go back. T-test, let me make this 67. All right, calculate. There's your information. All right, p-value. Okay, obviously the p-value is incredibly high because I didn't really look at the data. I could do the same thing under t-test. Let me change this so it's 70. Draw. Again, ignore the box plot. All right, the shaded area you can barely see because the test statistic's negative 4.4, but essentially you could do this and get the p-value. All right, if it's stats, just put in the null value, the sample mean, the sample standard deviation, the sample size, and then what's the alternative, less than, not equal to, and you'll have that. For a paired test, if you're doing this, remember you're probably going to have to calculate the difference. You'd have to change that to a list 3 when you do like list 1 minus list 2. All right, let's take a look at a two sample test. Data, if you have two independent samples, frequency is always 1. Your alternative, never pooling, calculate. For a two sample t-test, maybe you just have the summary statistics. So you put in the sample means, let's 85 with standard deviation of 10. The sample size is 20. Let's say 91, standard deviation of 15 with a sample size of 25. And these could be decimals. Let's say it's 15.2. All right, never pooling. Let's say it's not equal to, calculate. There's your test statistic. There's your p-value, degrees of freedom. The degrees of freedom for a two sample t-test will not be the same as the formula we used, just the smaller sample size minus 1. That's fine. Just write down the degrees of freedom from your calculator and know that that's there. All right? Because it's got to match up with your test statistic and your p-value. All right, so you got that. And the other tests, the other two tests that we talked about were the goodness of fit tests, which most of you have on the calculators, where you enter your observed in list 1, expected in list 2, and you have to put your degrees of freedom, which is number of categories minus 1. If you don't have that test on your calculator, you enter your observed in list 1, your expected in list 2, and then in list 3, you'd have to do like observed minus expected squared divided by expected. And you generate your chi-squared statistics for each one and sum that up. That's not most of you. For your chi-squared test, for test of independence, test of homogeneity, you're going to do the matrix. So under second matrix, edit, put in your observed values. Then you go ahead and you run your test. After you do it, it gives you your test statistic, your p-value, your degrees of freedom. And if you go back to matrix B now, you can see all of your expected values. Those are there. The last one, linear regression test or interval. Very unlikely they'll give you all the data. It's possible if they do, like on an investigative task, put the data into the list, and you're just going to run this and calculate. Oh, I don't have the correct information in there, but let me just show you what that would look like. All right, let me clear this out. Clear. Okay. Test. All right. Okay, so you're going to get this a two-tailed test, T, P, degrees of freedom, R, standard deviation of the residuals. You'll get your slope and your y-intercept. Unlikely, but it's possible. And the same thing with if you're doing a regression, like a one sample T interval for the slope, plug the data in. There you go. So that's a quick overview. If you have any specific questions on this video, make sure to email me or talk to me in class. But I'm going to make another video going through the assignment I'm going to give you on how to do this. So have a good day, y'all.